Hey everyone, what's up? Welcome back to the channel. Picture this, your client's behind a MikroTik router, cruising through a VPN tunnel, then bam, it drops. Internet dies? Calls cut off? Download stalled? Yeah, usually, unless you've got killer redundancy. Big question, how do we build failover so seamless the client doesn't blink? Better yet, multi-layers, GRE primary, IPsec backup, then EOIP or VXLAN, all auto-switching invisibly? That's what we're building today. Real-world setup with recursive routing on 2 MikroTiks. Step-by-step, tunnels, routing table, Mangle rules, distance-based routes, and live tests. Watch ping stay rock steady even when I kill the primary. If you need pro VPN or site-to-site stability, this is it. Stick around for bulletproof redundancy you can deploy now. Let's jump in. As you can see in my diagram, I have 2 MikroTiks, one called R1 and the other called R2. The IP of R1 is 77.127.44.110, and the IP of R2 is 98.77.156.202. Now, the first Ethernet interface, which you can see here, is connected to my cloud, and I can access it from Windows, or what I've named the MikroTik Access. The second Ethernet interface is designated as the WAN, meaning our internet connection, and I've connected it to the MikroTik. Then, the 10th port, or Ethernet 10, on the first router, the initial MikroTik, is assigned to the clients, and my client's IP range is 70.1.1.0/24. With a client IP of 70.1.1.100 on the other side. My second router also has Ethernet 10 assigned for internal clients, and the IP range there is 80.1.1.0/24, with the client IP 80.1.1.100. And as we'll see next, we want to establish a connection between the second Ethernet interfaces on both of our MikroTiks. And according to our diagram, we'll set up EAP, GRE, IPsec tunnels, and VXLAN. This way, our client, whose IP is 70.1.1.100, can connect through any of these tunnels, and if one tunnel fails, it will automatically switch to the next one without the client noticing any interruption, ensuring a completely stable tunnel. As you can see, I've placed the win boxes of both MikroTiks side by side, for MikroTik R1 and R2, and I've renamed Ethernet 1 to Winbox Access and Ethernet 2 to Ethernet 2 WAN. I've assigned their respective IPs, and just as you can observe in the diagram, I'm opening a new terminal and performing a connectivity test between both sides of the MikroTiks. Key connectivity test was fine, and now we'll go ahead and create the desired tunnels. First, from the interface list, I'll select the EOIP tunnel and configure the important settings. For example, I'll assign names, and you can choose any name you like. The tunnel ID must be the same on both sides, and I'll set it to 11 here. Also, the remote address should be the IP of each side, meaning both MikroTiks, and you'll place those IPs in the remote address field. As you can see, the connection for R has now been activated, and now it's time to assign the desired IPs for that EOIP we just created on both sides of the MikroTiks, both R1 and R2. I'll run a connectivity test to see whether the connection is established or not, and as you can see, the connection is fully established. We'll now set up the GRE tunnel on both sides again, and as mentioned, we can give it any name we like, and we'll place the desired destination IPs in the remote address field on both sides. After we've created the GRE tunnel, we'll then go ahead and reassign the desired IPs on each of our MikroTiks, that is, R1 and R2, and finally, we'll test it once more. After the ping test, the connection between both sides is fully established, and now I'll go back to the interface section and select the IP tunnel, and then I'll configure it just like before. You can give it any name you prefer, and in the remote address field, we'll place the desired destination IPs once again. And now it's done, and we'll once again assign the desired IPs for our IP tunnels on both R1 and R2 that we've set up, and after we've configured the IPs, we'll go ahead and test it. I'm testing the IP 30.1.1.2, and on the R2 side, I'll disable it temporarily to see if it gives me a timeout, and indeed it did give me a timeout, which confirmed that the connection was fully established. Then I'll re-enable it and see if the connection returns. Let's go to the interface section and set up the VXLAN. Once again, I'll give it a desired name, and here I'll place the target IP addresses on both sides, and then I'll click OK. In the VXLAN section, you can give it any name you like, and the important part is the VNI, which I'll set to 11 on both sides, and I'll set the port to 1122. There are specific settings that need to be configured. I'll go to the VXLAN tab and select the FDB and VTP options. If our VXLAN connection is established, it should fully appear in the FDB section. Then, I'll go to the VTP section and choose the interface on which we'll establish the VXLAN tunnel. The remote IP will be that of R1, and on the R2 side, I'll swap the remote IP to that of R2. As you can see, the connection is fully established, and in the FDB section, the remote router's IP is clearly displayed. I'll close the extra icons and then head over to the IP address section to set the VXLAN IP again. After I've configured the IPs on both MikroTiks, that is, R1 and R2, I'll run a connectivity test by pinging 40.1.1.2. And as you can see, my connection is fully established. And within my diagram, I'll power on the clients, and as the clients come online, I'll double-click on them so that the secure CRT opens for me. I'm going to the IP address section and entering the IP for Ethernet 10, that is, configuring the Ethernet 10 interface. And now, in the LAN section, I need to configure the desired LAN settings on both sides, that is, on R1 and R2. Once I've done that, I'll head over to the IP DHCP server section, so that my clients can automatically obtain their IP addresses from the MikroTiks on each side. After I've configured the IP address, I'll head over to the IP DHCP server section and set up the desired DHCP. Now I'll open the terminal on PC1, which is the client, and I'll type in IP DHCP, and as you can see, it easily obtains the IP 10.1.1.100 from the DHCP server. And I'll apply the same settings on the R2 side, that is, on MikroTik 2. I totally forgot. I was supposed to use the 70 range for MikroTik 1 and 80 for MikroTik 2, but I ended up using 100 to 200 instead. Now I need to go back and redo the IP DHCP server settings. I cleared the DHCP server settings and set it up again. And as you can see, it's now correct, and router 1 has assigned the IP 70.1.1.100 to your client. I'll apply the same settings on R2, router 2, as well. By running the show IP command, you can see the information received from the DHCP server and find out which IP has been assigned to each client. As you can see, the connection between client 1 and client 2, the client on the R2 side, is still not working when I ping 81.1.100. In this video, I'm going to show you how to set up recursive routing. As you can see, in the Tools section, when I select the interface and run a ping, the connection is fully established. Now, according to the diagram, I need to set up recursive routing so that the client doesn't notice any interruption if the connection drops. I go to the IP firewall NAT section and configure the NAT settings I need. Then I head over to the Mangle section and create a new rule, set the chain to pre-routing, and for the source address list, I pick VPN. In the Action tab, I select Mark Routing, but the routing mark hasn't been created yet. So, I go to Routing Tables, click the plus symbol, give it a name like VPN, check the FIB option, and click OK. Then I return to the same Mangle rule, set Mark Routing to VPN, hit Apply, and OK. And that's it. I'll go to the Address List section and click the plus symbol. Then, in the List field, I'll select the same VPN list I had before, and in the Address field, I'll copy and paste my client's IP, which is 70.1.1.100, then hit Apply and OK. Okay, before we dive fully into setting up recursive routing, I'm gonna run some quick tests from PC1, client 1, and as you can see on the screen, the EOIP, GRE, IPIP, and VXLAN tunnels are all up and working fine. The only thing missing right now is connectivity to the client IP, which is 80.1.1.100. Okay, next up, I'm gonna set up the IP tunnel and configure its routing as well. In the same way, now I'm setting the distance for the IP tunnel to 2, and I'm gonna follow the exact same steps I showed in the plan. I'll create another new route, set the destination address to 0.0.0.0/0, and for the gateway, I'll pick the IP tunnel. The really important part here is that I set the distance to 2 and select the VPN routing table. So if the GRE tunnel goes down for any reason, the client won't even notice, and the connection between the two MikroTik routers, R1 and R2, will stay up through the IP tunnel 0.1.9 as fast. In the same way, I'll do the exact same thing for the VXLAN tunnel now, and I'll set its distance to 3. Okay, now from PC 1, client 1, I'm gonna ping the IP 81.1.1. Look at that, we've got full connectivity, packets are going back and forth no problem. Now I want to test if this recursive routing we set up is actually working properly. As you can see on the screen, first I'm disabling the VPN routing table, and the ping is still going. That means traffic is falling back to the other routes. Next, I'm gonna bring down the IP tunnel as well. Check this out, it switches over to VXLAN, but unfortunately for some reason VXLAN isn't working right now and the ping drops. I bring the IP tunnel back up, and as soon as it's up, connectivity is fully restored. Perfect. Alright, let's test it one more time with our main client IP, which is 81.1.100. Before I run the ping, I'll just quickly check the IP firewall NAT section. As you can see, the counters are ticking up nicely, traffic is going through NAT just fine. Everything looks good. Now I'm hitting the ping. I really want to figure out why the VXLAN tunnel isn't working right now, so I'm just gonna replace it with an EOIP tunnel and see if that fixes the problem. Alright, I went ahead and did that, and unfortunately, it still didn't work. But seriously, the settings are exactly the same, nothing else is different at all. I think it's probably just the simulation environment, like EVE-NG, messing things up and causing this weird behavior. In the real world, with this exact same configuration, it works perfectly, no differences whatsoever. 0.2.2s fast. Alright guys, as you saw, the whole recursive routing concept with multiple tunnel layers, GRE as primary, IPsec as backup, and VXLAN or even EOIP as the third, works perfectly and gives a super clean failover without the client noticing anything. The only hiccup we had here was because of some limitations in the EVE-NG simulation environment that doesn't fully support certain tunnels, but in the real world, on actual MikroTik hardware, this exact same configuration runs flawlessly, no issues at all. If you implement this on your real routers, you'll get rock-solid redundancy. Hope this video was helpful for you. If you've got any questions, drop them in the comments, I'll reply. Don't forget to like and subscribe. Catch you in the next one, take care.